Hello, so this is off of written assignment number 3, and this is number 3 off of written assignment number 3, and we are asked to find the equation of the tangent line. So the equation of the tangent line of the curve defined by this equation here, defined by e raised to the x over y, is equal to 3x minus y plus 2, and this is going to be at the point 0, comma 1. Okay, so how can we find the equation of the tangent line? Well, we can go ahead and just, first of all, go ahead and differentiate both sides of this equation with respect to x, because to find the equation of a tangent line, we basically need the slope of the line. Well, the slope of the tangent line is given by the derivative. So we want the derivative of this function at the point 0, comma 1, and then just a point on the line. We can go ahead then and use point slope form. Well, if we go ahead and try to differentiate this equation, we have e to the x over y on the left side. So if we go ahead and differentiate, we're going to have to use implicit differentiation whenever we see a y, because y is going to be defined, well, implicitly. We just had an x. I mean, the derivative of e to the x, that's real nice. That's just e to the x. But we have e to the blob. So there's actually a chain rule here. The derivative of e to the blob is e to the blob. So the derivative of e to the blob is e to the blob. The blob here is x over y, but then times the derivative of the blob, where the blob is x over y. So we have a quotient there. We got to go ahead and use the quotient rule. So the derivative of e to the x over y is, again, that's e to the blob. The derivative is e to the blob, and then times the derivative of the blob. So the derivative of x over y by the quotient rule, that's going to be the bottom. So the bottom is just y times the derivative of the top. Well, the derivative of the top is just x. The derivative of x with respect to x is just 1. So that's the bottom times the derivative of the top, which is just 1. And then minus the top, which is just going to be, well, minus the top is x. But then times the derivative of the bottom. Well, the derivative of the bottom is just the derivative of y with respect to x. There's a name for that, and that is dy dx. dy dx is the derivative of y with respect to x. So we have the bottom y times the derivative of the top minus the top times the derivative of the bottom, and that's all divided by the bottom, which is just y squared, all over the bottom squared. So that's the quotient rule. Okay, that's just going to be the derivative of e to the blob, and that's equal to, well, 3x minus y plus 2. We go ahead and differentiate that with respect to x. The derivative of 3x is just going to be 3, and then we have the derivative of y. Well, that's dy dx, so we have minus dy dx, and then that's going to be just plus, well, the derivative of a constant is 0, so the derivative of 2 is 0. Now, looking at this, what can we do? Well, we want the derivative at the point 0, comma 1. At the point 0, comma 1. So we go ahead and plug in 0 for x and 1 for y. What do we got? Well, that's going to be e to the 0 over 1. It's just e to the 0. So e to the 0, that's just 1, right? Because anything to the 0 power is 1. So we have e to the 0, and then that's going to be multiplied by, well, y times 1 is just going to be y. And then, well, minus, okay, well, yeah, it's got to be y, but remember, y is 1. So y is 1. Let's go ahead and put that in. Y is actually 1 here, so we have e to the 0, which is 1, times 1 minus, well, x is 0. So 0 times dy dx is just 0. So minus 0 all over y squared. Y is 1. So over 1 squared, which is just over 1. Well, 1 minus 0 is 1 over 1 is 1. This is just e to the 0, which is 1. This is 1 times 1 over 1. So this is 1 times 1, which is 1. So we have 1 is going to be equal to 3 minus dy dx is equal to 3 minus dy dx. We want to solve for dy dx. We want the derivative. So we could go ahead here and just, we could add dy dx, subtract 1, and say, well, 3 minus 2 is 1, right? So therefore, dy dx is just equal to 2. Okay, so there we have, if dy dx, that's the derivative, and we have a point, right? We have a point 0, 1. So remember, point slope form says if we have any point on the line, so the point can be, let's say, x1, y1, any point on the line, and we have the slope m, then the equation of the line in point slope form is just y minus whatever the y is. So y minus y1 is equal to the slope, call that m, times x minus whatever the x is, so times x minus x1. And so we have the slope, because the slope of the tangent line is the derivative at that point. Therefore, the slope of the tangent line at the point 0, 1 is 2. So therefore, we just say, again, the point is 0, 1. So we have a slope and we have a point. So therefore, in point slope form, it's just going to be y minus the y. So y minus 1 is equal to the slope, which is 2, times x minus the x, so times x minus 0. This just becomes y minus 1 is equal to 2 times x minus 2x. If you want to go here and add 1 to both sides, that y is equal to 2x plus 1. So there we have it. That is the equation of the tangent line to the curve defined by e to the x over y equals 3x minus y plus 2 at the point 0, 1 is just going to be y is equal to 2x plus 1. All right, calculator, take care.